This video will cover about section 5.1, which is called polynomial functions. We will have some questions about how do we decide if something is a polynomial function or not. And then we're going to actually find the polynomial when the zeros are given. So the first question here is, determine whether the graph could be the graph of a polynomial function. If it could be, list the zeros and state the least degree the polynomial can have. So when we have these polynomial functions, one thing we want to make sure that when we meet with the x-axis, these are called the solutions or zeros. So for this function here, it touches to the x-axis over here, which I'm going to say that -2 is a 0. And then it touches to the x-axis again at x equals 0. And then it touches to the x-axis one more time, 1, 2, 3, 4, 5, that's a +5. So, and polynomial functions, they will either start low and end in high. I'm talking about their end behaviors, how their graph looks like. So end behaviors of these functions, they can do up, up, or down, down, or they can start low and end in high, or they can start high and end in low. So we're going to choose, yes, this is a polynomial functions, and the zeros are -2, 0, 5. Again, real zero means when the graph touches to the x-axis. Only when the graph touches to the x-axis, these are the x-intercepts. So we can use either x-intercept for 0. So for when we talk about polynomial functions, for zeros, we can use multiple different names. We can say that the polynomial function have zeros. They have x-intercepts, where the graph crosses with the x-axis, or they can have solutions. They all mean the same thing when we talk about polynomial functions. And then the least degree of the polynomial can have is 3. If there are 3 solutions, 3 zeros, we expect to be minimum degree to be 3. If there were 4 solutions, we expect them to be 3 here. Now for the question 2, it says, we have this polynomial function and it has the 0, 9 and its multiplicity is 1. There's another 0, 4, its multiplicity is 2. The degree of the polynomial is 3. So we're going to type a polynomial function with integer coefficients and the leading coefficient 1 in the box below. Before we answer this question here, we want to have some general understanding about the zeros and the multiplicities. So when I have a polynomial function, let's say f of x is equal to this polynomial function, we can write it as x minus 1 to the second power and x plus 2. This is a polynomial function, and it's already factored for us. And then for this polynomial function, x minus 1 is a factor of this function. And then when I set x minus 1 to a 0 and solve for x, x equals 1 is a solution. Or another name for solution is you can also call it a 0. And then multiplicity of this 0 is just the power associated with the factor. So the power associated with x minus 1 is 2. So the 0, 1 is going to have a multiplicity of 2. Now this function, this is not the only 0 of this function. There's another factor following this x minus 1 squared. So we also see that x plus 2 is a factor. So when I set x plus 2 to a 0, and solve for x, I'm going to get that x must be equal to a -2. And -2 is a solution of this function. Or you can call it a 0 if you like, solution 0. Either one is going to work. And then this time the multiplicity for -2 will be whatever the exponent for this factor when there is no number. That means always power of 1. So the multiplicity will be 1. So when a function is given in factored form, it is easy to find the zeros and their multiplicities. The same question, if they actually expand x minus 1 squared times x plus 2 to the first power, look, that same function, x The first one was x minus 1 squared, x minus 1 squared, and then times x plus 2. Now, if we first expand x minus 1 to the second power, it means x minus 1 times x minus 1. And then when I multiply them, x times x is x squared, x times negative 1 is negative x, negative 1 times x is negative x, and negative 1 times negative 1 is positive 1. When I combine the like terms, this is what I am going to get when I expand x minus 1 to the second power. Now, this x squared minus 2x plus 1, we can also multiply it by x plus 2. So x squared times x is x to the third power. X squared times 2 is 2x squared. Negative 2x times x is negative 2x squared. Negative 2x times 2 is negative 4x. 1 times x is x. 1 times 2 is 2. So we're going to get x cubed here. And then this and this happens to cancel out. And when I combine the negative 4x and positive 1x, that's a negative 3x plus 2. So if I graph x cubed minus 3x plus 2 using a calculator, it will be the exact same graph as graphing x minus 1 squared times x plus 2. So on this very first function form, we have the polynomial function factored. What is the advantage of this factored form? So I can easily find the zeros. One zero is positive 1, the other 0 is negative 2. And I know that when positive 1, its multiplicity is 2. When your 0 has an even multiplicity like 2, the graph is going to touch to the x-axis at that point and will turn around. So this is what the even multiplicities behave, where when your 0 has an odd multiplicity, the graph doesn't touch and turns around. The graph will just cross the x-axis like this. It will just move to the other side of the x-axis. So this will be the difference between an odd multiplicity and then even multiplicity. So this one is going to have even multiplicity behavior. And then this one will be the odd multiplicity behavior. And then if you just expand all your factors and organize your function, this one doesn't really tell you much about the zeros, but it does tell you about things like the end behavior of the graph. How is the graph going to start? How is the graph going to end? Because we have 4 rules about the end behaviors depending on the degree of the function and the leading coefficient of the function. The degree is the highest exponent in your function. For example, here, when I look at my final answer for this polynomial function, the degree is the greatest exponent. So the degree is 3. And the leading coefficient is the number in front of the highest exponent. So since we have x cubed here, and then we have just one x cubed, so the leading coefficient will be 1, and then the degree will be 3. This is just a general information about polynomial functions before we go back to our homework. So for our homework, for question 2 here, now we have a 0, 9. So I'm going to write the factor. If the 0 is 9, the factor must be x minus 9. So when you set this to a 0, it gives you a 9, and its multiplicity is 1. So it's going to have a power of 1. And you don't even have to write when it is 1. Next 0 we have is 4, and its multiplicity is 2. So the factor associated with this 0 will be x minus 4. And then its multiplicity is 2, so I'm going to have a power of 2. And then it's already degree 3, so I don't need an additional factor. Look, here, power of 2 and power of 1, when I add them up, it makes a power of 3 total. So this would make my function. So once we find this, they want us to expand them. So we're going to write the x minus 9 again. I'm going to first expand x minus 4 to the second power. One option will be write x minus 4 and x minus 4 and then do the FOIL method as I showed earlier, okay? Or there's a formula we can always use when we are working with this type of binomials. The answer will be always the first number squared minus, you will multiply these two numbers, a times b, but then you will always multiply them by 2, so you will need a minus 2ab in the middle, and then plus b squared. What you're gonna have here for a minus b squared is gonna give you this answer. So I'm gonna apply this formula over here. So the formula says square the first one, so that's x squared. Multiply them 4x and double them 8x. And then 4 squared is 16. This is what I need to get when I multiply x minus 4 by itself. So here, I want to just open some room to continue. Next, we're almost done with number 2. We're just gonna multiply them again. X times x squared is x to the third power. X times negative 8x is minus 8x squared. X times 16 is 16x. Negative 9 times x squared is negative 9x squared. Negative 9 times negative 8 is plus 72x. And negative 9 times positive 16 is, that's a negative number. And then 9 times 6 is 54. 5 is the carry, so it's going to be negative 144. The last thing is, I'm just going to combine the like terms if there's any. We have the x cubed here, negative 8x squared and negative 9x squared. These two are the like terms. Again, like terms means they have to have the same letter and same power. So negative 8 and negative 9, when I combine them, that's total of negative 17x squared. And positive 16x and positive 72x, when I add them up, that will be total of 88x. And the last number will be minus 144. So this is what we are going to get for question 2 on the homework. So this box on homework, you will have to just type for these numbers, of course. I get x cubed minus 17x squared plus 88x minus 144. That's how we answer number 2. So we have a lot of questions in this format. So I'm going to just model this problem type one more time. But if you don't understand anything clearly, make sure that you watch the question solution multiple times. Now, number 3 is a similar problem. We want to still find the polynomial. Its zeros are given, the degree is given, and then we're going to find the function. So if negative 1 is the first zero, I'm going to just write the factor. X plus 1 is the factor, again, because when I set this to a 0, x becomes a negative 1. The other one is x minus 0. Why? Again, when I set this to a 0, x is equal to 0. When it is x minus 0, I don't have to keep it complicated like this. Minus 0 doesn't change anything, so I'm just going to erase it to make my work simpler. So I'm just going to write x. So when your factor is just x, your associated 0 will be just a 0. And the last factor I need here is x minus 8. Again, when I set this to a 0, I get 8 as the solution. Now, once we set up these 3 factors, it is time to FOIL. You can FOIL them any order you like. So in this case, I'm going to first FOIL x plus 1 by x minus 8, because then multiplying them by x will be very easy. X times x is x squared. X times negative 8 is negative 8x. Positive 1 times x is positive 1x. And then when I multiply these two, I get a negative 8. Let's just combine the like terms. So only these two are the like terms here, negative 8x and positive 1x. That's total of negative 7x minus 8. To find the answer to question 3, one last thing I have to do is what I got here must be multiplied by the other left factor, x. So this answer I got here, x squared minus 7x minus 8, I have to just multiply them by x. So x times x squared is x to the third power. X times 7x is just 7x squared. And x times negative 8 is negative 8x. So this answer will go to this box over here for given zeros like this. And it's a very similar question. Number 3 and number 2, they are the same type. Now we want to do the number 4 here. So I can just erase what I did here to open space to myself. I'm going to, And then here, for number 4, again, it's the same type of question. I have just different zeros to work with this time, and the degree is 3. So I got the hang of this after probably the second example, but let's just do this again. First zero is -4, so I'm gonna write this as a factor of x plus 4. So when I set this to 0, x is equal to a -4. The second factor I need is x minus 4. And then the last factor I need is x minus 8. Okay, and then we need the degree 3. So 3 factors, they mean the 3 zeros most of the times anyway. Again, you can pick them any two you like, but I'm just gonna pick these two because x plus 4 times x minus 4, it's very easy. They will always return x squared minus 16. If you don't remember this rule, remember the factoring lesson. If you happen to factor x squared minus 16, both of them are called difference of two squares. This is x to the second power, this is 4 to the second power. So you would always factor them as x plus 4 and x minus 4. So first, I multiplied these two and I got x squared minus 16. Now I'm going to multiply them by x minus 8 to construct my final answer. X squared times x is x to the third power. X squared times -8 is -8x squared. -16 times x is -16x. Negative times negative is positive, and 16 times 8 is 6 times 8 is 48. 4 is the carry. So this will be the answer for question 4 when we need to find the polynomial when the zeros and the degrees are given. This assignment, I believe, has total of 8 questions. So we're going to move to number 5. So number 5 is not this type anymore. It says that you're going to decide whether this one they gave me is a polynomial function or not. If it is a polynomial function, we're going to tell the degree. And if it is not a polynomial function, we will tell them why it is not. And then we're going to write them in standard form. So we need to discuss what standard form means. And then we need to identify the leading term and constant term. Now, we're going to say that this is not a polynomial function here, what they give me, x to the power of 7 over 2 minus x to the 4 plus 6. The reason it's not a polynomial function because oh, no, not this one. Sorry. There are two answer choices where it says it's not a polynomial and it's not a polynomial, and the last option, it's a polynomial. So this will not be a polynomial function because look, one of the x is raised to the 7 out of 2 power, which is not a non-negative integer. Okay, so what happens is when you have a polynomial function, you cannot have a fractional power like this. Your powers have to be all positive numbers, and it has to be a non-negative integer. So again, 7 over 2 here in this problem is not an integer. 7 over 2 is a fraction, not an integer. This is the problem. So whenever one of your x has a fraction like this, your function is not going to be a polynomial function. Or if whenever your x has a power of like -5, then it will not be a polynomial function because it's not a positive number. So your powers, rule number 1, they have to be positive numbers. And then rule number 2, they have to be integers, whole numbers. Okay, so we're going to choose A. Now, because it is not a polynomial function, we can't put this in function in standard form. Again, standard form means from highest exponent to the smallest exponent. So if this was like a 3, I will move to the negative x to the 4 to the beginning, and then x to the third will be in the middle, and 6 will be the last. But whenever it's not a polynomial function, you say just the function is not polynomial. Number 6 is the same type of question. Again, we're going to decide if this is a polynomial function or not. And we have this time 6x plus x cubed. So we're going to say this time, yes, it is a polynomial function because the powers are 1 and 3. They're both positive numbers and they are both whole numbers. So there is no fractional exponent. There is no negative exponent. So everything is in good shape. And the degree is the highest exponent we see. So the highest power I see is 3. So the degree will be 3. Now we're going to have to write it in standard form. Standard form means we have to write the x cubed first. So f of x is equal to x cubed is going to go first. and then plus 6x is going to go last. So this is called standard form. When you write your function from highest power to the smallest power, its leading term is x cubed. So x cubed is the leading term. And the constant of this function is 0. So the constant is the last number at the end here without an x. So in this case, the constant number is as 0. So you will mark A for number 6. For number 7, we want to again decide if this is a polynomial function or not. So 4x cubed minus 3 minus 6x squared minus square root of 2. Now, if square root of 2 was one of the powers, it would be a problem. But square root of 2 is a constant, so it's not a problem here. So we're going to choose, yes, this is a polynomial function, and its degree is the highest power, which it will be 3. And having a radical number at the end as a constant is no problem. But having a radical with the x will be a problem. The last question on 5.1 is we have a graph given and we need to choose the correct function for this graph. So when I understand the graphs, I'm going to make it a little bit bigger so I can see the zeros better. Now here, one of the 0 is 0. So let's just write the zeros from the graph. I see a 0. And its multiplicity is an odd number. Why? Because it's not touching and turning around. It actually just moves to the other side of the x-axis. So one of the 0 is 0. The other 0 is, so let's just write this as 0. Number 1 is 0. 0 number 2, it touches to the x-axis again when x is 1. And then the third 0 is 3, positive 3. If we just write the factors associated with each of these zeros, this is x minus 0. Simply, we're just going to write it as x because subtracting a 0 doesn't change anything. This one is x minus 1. That's what I need. And this one is x minus 3. Because these two zeros are positive, their factors will have negatives. Look, this is gone because it's x plus 3. This is gone because it's x plus 3. Now, here, the only thing I have to decide is whether the answer is B or C. The answer will be C here because if x has a multiplicity of 2, it will touch and turn around. So the graph will be actually like when it is 0, you will touch and turn around without going to the other side of the x-axis. Then you will touch 1 again, and then you will touch 3 again. But that's not what the case is. X must have a odd multiplicity because it just touches and moves to the other side. That's the rule when you have an odd multiplicity. This takes care of 5.1, which is polynomial functions.